Hello, everyone. I hope everybody can hear me. Lots of talks going on. So I'm Frank Weigel. I'm the Chief Product Officer at Matillion. I've got Julian with me. He's the Chief of AI. And we're going to talk to you about the looming crisis in data engineering that you might not be thinking about at all. So we'll talk about it. We'll tell you a bit how AI can help you with it. And then at the end, you get the best part, which is you'll see a demo. And wow, already that apparently was not hitting the spot for some people. So everybody in this show, right, is talking about AI. No surprise. All of you know the amazing stats about how agents will take over the world and all your business people will start interfacing with agents in order to get their job done. Now, I don't think there's anything that will stop this. This will happen. But for us as data people, there is a major problem here that I'm not sure all of you are thinking about it. And so hopefully you'll find this a little bit interesting and it makes you think. So if we look today at data engineering, right, we've got supply and demand. We've got a whole bunch of data sources. And then you've got your humans across the different disciplines all wanting data. And you and your data teams are working hard to create those pipelines to put the data in the right form in the data warehouse. And we've never met a data team that said they had enough people to do this. So typically the business is a little unhappy because not all the data is arriving quite as fast as you want to. Now, traditionally, what we at Matillion do is we offer something called DPC, Data Productivity Cloud, which is kind of an end-to-end low-code, no-code data platform to help you with this. And so, because it is low-code, no-code, and offers all these, I think I just lost my mic. It offers you all the advantages of making the task easier. It means that, we have all these studies where it shows that people can end up doing this 3 times faster, so compared to traditionally like writing code and other things. But that looming problem that I'm talking about is that the world is changing. It's changing with AI in 2 folds. Supply of data is increasing, right? So you now have suddenly all these unstructured data sources that historically we couldn't really do very much with. But now suddenly we want them in the data warehouse because with AI, I can go and extract really interesting knowledge out of it and combine it with the traditional transactional data. And so you have a huge increase in supply of data. But much more crucial, you also will be facing an increase in the demand for data. Because in addition to all these people, you now have people that will use agents. So why does this matter? Well, think about it, right? So you have your BI or your analytics person or even just your marketeer, they all will have a front-end agent that they will use and that they will ask all these questions to. The agent will go and will break it up into steps. And then one of the steps will be, I need data. And at this point, I think all agent vendors today are cheating. Because if you look at what they're doing in their demos, they just connect these front-end agents directly to a database in the back, right? Because everything can query a connector or write some SQL and write a query. Great demo. I mean, very impressive. The problem is, right, this is the dark ages. This is describing exactly why we invented data warehouses in the first place. Because when everybody just went directly to the data sources, we ended up having a range of problems. We ended up, everybody just ran their query a bit different, and you didn't have any sort of central control and definition of things. Every VP, every director ended up with a different number as their number. That's the right number, right? And then if you're working at scale, what, you're going to give every of these agents the ability to write into your transactional database to create the tables? Like, I don't think that's the world we want to go back to. But that's the world that the agent creators really are talking about because their agents always go directly to the source. Why are they going to the source? This is where what we call that machine to human scale a mismatch is happening today. because the agents work at machine scale. And so if you have humans on the data engineering side trying to build pipelines for automated agents, good luck with that. If you thought you were busy today, you're going to be completely overwhelmed then. So therefore, we're postulating that the only way really to be able to deal with this is you need to match machine scale demand with machine scale generation of pipelines. Because only this way can you still have a central data warehouse where you have central control, central governance of your data, of the pipelines, but you now do it not only for the requests from humans, but also for machine scale requests coming from AI agents. And remember, these AI agents won't even always be backed by a human. We'll end up in a world where we'll have the fully autonomous business agents looking after certain business processes. And we know nothing will happen without the relevant data. And so a lot of what we'll be talking about for the rest of the time is really all about how does this virtual agent work. So Maya is what our product is called, and it's really about creating this virtual data engineer that your teams partner with in order to increase your bandwidth incredibly. It's something your data engineers use in order to have much higher productivity, but especially it's something that enables you to scale up the generation demand to meet whatever your business wants through AI agents by doing agent-to-agent communication. So let's dive into this a little bit. And at the end, there is a demo, because I know with these agents, like everybody has an amazing AI, whatever. The thing is, the proof is in the pudding. And if anything, I can tell you that where we like to stand apart is it really works. And many people might say it, go to our booth and try it out hands-on. You'll find it really does. And I think we're talking about why a little bit later. So this is what we just talked about it. Maya enables you to do that machine scale enablement for your data team so it can cope with the machine scale demand, exposed through MCP or A2A so that your agents can directly communicate. We don't try to do the business logic. We just make sure that the agents will have the data from the central team. And Maya is you end up giving it certain context, so it will know about everything from your naming scheme to, of course, your data context. And so the pipelines it generates will follow all the best practices that you today have in your company. You can give it a document that you would give to the new data engineer. So it's not just generically creating crap that might work but isn't really up to par. It will create stuff that looks just like the other pipelines your team is building manually today. Now, and that's kind of this what we call augmenting the data team, because all these benefits don't just work if you have an agent asking for it. It, of course, also works very much so if you have a data engineer working with it. We're fully bidirectional, meaning like I can work on the pipeline that's being generated manually. I can make some changes to it, and AI can pick it back up from there. So it's really this collaborative working, just like a real human virtual data engineer, just in the virtual kind of form. This also, by the way, works great for less technical people. So we often hear that the folks asking your team for data pipelines, out of BI teams, for example, right? They know a bit about data, maybe use something like Alteryx today, but you wouldn't trust them to build a pipeline directly on your data warehouse. With this, they can go and easily build pipelines that adhere to that standard on the same platform. You can still go and use your full CI/CD process on top of them, all your workflows, but they can generate them through the natural language interface with the virtual data engineer. And this consolidation isn't just the users, it actually works even for platforms. That was something that honestly was a bit mind-blowing for us, because people proposed it and we were like, oh, this sounds neat, we should build something, and then we tried it and it actually already works. So what it does is, a lot of the legacy formats, whether it's Informatica, whether it's Alteryx, whether it's just various SQL dialects, because it's, of course, backed by the LLM, it understands them. It can parse those and understands the meaning, the semantics of that. We taught it about how to build pipelines in DPC. And we're low code, no code, you'll see it, it's graphically. And that actually turns out to be one of the key advantages why it works so much better. Because instead of asking your agent to just write a book, SQL, meaning like free-form text, we are asking it to select one of the 120 or whatever components. Those components self-validate. They then generate the SQL for the specific data warehouse that's underneath it. And this self-validation of the components that feeds back to Maya something isn't quite right means we can discover errors much, much earlier in the process than anything that needs to first write complete SQL and then run it and then try to troubleshoot it. It also means you don't end up with this kind of spaghetti code that you would often if you go and iterate on a pipeline with AI. Here you get the very nice graphical pipeline. It modifies it. It's literally indistinguishable from anything you've built, and you can, as I said, modify it. And so that means that you can also consolidate different platforms. So you can basically take existing pipelines, and Maya will help you convert them onto top of DPC. So these are kind of the key things where we see at the moment customers get excited. The consolidation of platform, the exposing to more user personas, the augmentation of your data engineering team, which is already overloaded to be able to do a lot more. And then, of course, what we mean here with roadmap acceleration is all around being ready for when AI agents want more and more of your data, and you need to be able to meet that machine scale demand. And so with that, we come to a nice double helix, and I hand over to Julian. Thank you.
How does a system like this actually change and make your team more productive? It's not just adding extra units. It's changing the level at which people operate. So this is a view about how you might assign tasks within an existing team. Ignore AI in the picture for this slide. Imagine that you've got a technical task coming into your team, in this case data engineering. The first time you've got a new technical task, it probably goes to the most senior technical lead in the team. It's a challenge for them, they've got to learn, they've got to figure it out. But they learn a bit about it, becomes less complex. Second time around, maybe the same person repeats. Again, they learn, the technical skills going up, and the complexity in the red is coming down. Maybe the third or fourth time, though, the technical lead hands it off to a senior dev. It'll be a learning experience for them. It's old hat for the technical lead. It becomes a bit routine. And on down the scale. Oh, sorry, get back one. With repetition, tasks become easier. They can go down the stack, and the junior dev's task, the guy fresh out of university, is doing the task that will be a bit boring to the tech lead and a waste of their time. How does AI change this? Everybody's moved up the stack a notch. The tech lead is working at a level that nobody's worked at before. The senior dev is doing what the tech lead was doing previously. The junior dev is now working like a senior, and the more business user, business analyst, is as equipped as a junior dev to self-serve, get their own data, otherwise chase it. So nobody's totally being replaced, but everyone's able to operate at a much higher level than they were previously. Just try and build this out. Let's sit down and self-serve. So, kind of various ways in which we've plugged Maya into the system. We'll show you a little bit. Building pipeline zero in natural language, configuring API connectors, taking the API documentation, reading it, building out that API, super powerful. Root cause analysis of error messages, very handy, saves people a lot of time. Checking for data quality. Automated generation of documentation, Git commits. It's the sort of stuff we should all be doing, and we never have time to, we never get round to. Letting an AI generate documentation for your pipeline, very handy for your colleagues, very handy for yourself in 6 months' time, very handy right now for sanity checking. The business logic is actually what you thought you built. We talked about conversion. How's it working? This is the secret sauce under the hood. In the top right, we have a sample of what we call data pipeline language. It's just a YAML format for configuring our components. It was a really interesting lesson when we got started on this about 2.5 years ago. We assumed that this would be impenetrable to the LLMs of the day because they'd seen tons of Python, they'd seen tons of SQL. This was totally proprietary. It had never been seen outside the company. But we had designed it to be human readable. And that what we found, almost a little bit by accident, was that the models could read that perfectly well. And once they could read it, they could write documentation, And that then taught us how to write it and edit it. And then the changes when you edit it are reflected in this graphical pipeline. And as Frank mentioned, the key we're offering here is, because you've got this graphical pipeline, it's really clear the logic of what's going on here. It's really easy to unpick. If I've had an LLM write me 300 lines of SQL, it's going to take a while to check I really understand that. But here I can sample all along the way. I can see what it's doing. I can check that it's built what I want to. Talking of accidental discoveries, another accidental discovery we found was that the LLMs localized our product without even trying. They happily understand German or Japanese inputs and respond in kind, which is really handy. But broadly, you've got the cycle of asking business logic, get an edit, get business logic back in terms of what it's doing. Here we have kind of our agent structure, what's going on. Without digging into an architectural deep dive, we have analyst agents, Maya operating here, telling the Matillion agent what to do. The Matillion agent acts as a control plane, pushing down the SQL or Python to the cloud data warehouse, whether that's Snowflake, Databricks, Redshift, or similar. So we act as a control layer over your data. And that's always been our use case. Okay, I'll cut over to a little bit to talk about kicking off the demo and let you see it, and then I might come back to the slide. So if I bring up the Matillion screen here, here's our kind of UI. I'm just going to ask Maya a little bit about what data I've got here. I'm not sure. Hey Maya, what data available here? I'm going to give it a hint. I've given it a data landscape file, so give it a little clue. But I'm going to ask it, so just what data is available in this warehouse, and start to explore. And see, we've got a thinking step here. This is the agentic framework kicking off, saying, okay, what can I do? It's called a tool to explore what's in the context files, what's available as notes, and what it can see as tables. Here I've got me some utilities data. This is fairly dummy data. This is power generation, talking about grid infrastructure, customer consumption. What's a logical thing we might want to do with that? Well, let's ask about, see if my generation actually matches supply. So I'll say build a pipeline, see how supply compares to demand by region. So fairly logical business request. Okay, I want to match up to see if there are any regions in my data that are undersupplied. What you'll start to see, hopefully on the right-hand side, unless something's gone horribly wrong, is Maya will start to build out one of those pipelines, as you saw in the screenshot earlier. It's saying here it's found some relevant tables, probably fairly easy because it's a relatively sparse demo warehouse. Over time, one of the things we're looking to work at in the future is more and more sophisticated abilities to guide Maya on your data landscape. So you see it starting, it's created an empty pipeline. And now it's going to start to think about what data it needs. It's probably going to ask me for permission to sample the data at some point soon, because it can work without sampling the data if you're really worried about privacy. We wouldn't advise it though, because it kind of really hems Maya in, because what data engineer could work without actually occasionally checking samples? It is relatively stateless, however. So it's looking at what components it's got in its library. I can check into one of these thought steps here. What's it found? So it's saying, okay, the sort of things I need to work with here are table inputs, possibly rewrite tables, joins, and calculators. It's going to need an aggregator. So it started with saying, all right, it's found its generation metrics. It's a component. Zoom out a little bit. See the screen. So you see it's got put a table input in here, which is starting to say generate a table. It's going to ask me for permissions down here, I'm sure. Yeah, it said, can I sample? Yeah, you can have a look at my data. This is nice and safe. A lot of the time, we would imagine teams would also be working with Maya in their dev environment to build out the pipelines. And then when you're happy with it, push it up to your production environment, particularly if you've got particular privacy concerns. So here it's now added an aggregation step. Clear this off. So here I've created a group by. Again, as you can see, because we're a low-code environment, it's relatively easy to say, okay, it's done a group by region. It's going to aggregate the generation megawatt hours here. I can look under the hood and see what SQL each of those pieces are generated if I want to. As it builds out, it's added a separate table. And it's realized it needs to do some calculations here. Wants to aggregates the group by region. Again, relatively simple example. This ability to go work at scale, it can be quite detailed. It can quite happily build multiple pipelines for a job. When you're debugging, it can work through. I've seen it work through. I've had a 12 pipeline stage that was failing and identified that it was failing in pipeline number 8 because in pipeline number 4, one of the variables was misnamed. So that kind of threading the needle is really helpful when we're driving there. See how we're getting on. It's then built us out a join. So I can see that it's identified the keys in this space. I should be able to sample my data here, take a look at how it's getting on. Yeah, so I can see it successfully made the join. Chugging along here. And it's now doing a supply and demand calculation. What have we got going on here? Saying just total demand, total supply, looking at ratios, looking at percentages. And it's created a rewrite table piece, or target table to generate that, where to dump that analysis out to. So I'll let it keep chugging. It'll probably come back with some commentary as it samples. Again, the sampling and the validation is a key piece of how Maya's working here. While it's editing that YAML, that resolves into stuff in the UI. It then either gets samples back or validation results. If it can see everything's green, it knows it's good. See, we're here. So let's have a look. It's given us some insights about how one particular region has a very strong ratio. So huge oversupply in the northwest region. And I can sample this and take a look. Okay. You can see there, supply to demand ratio, supply status. It's created a calculation there to say, is it in surplus or not here, with a case statement. Now, this is a relatively trivial example, but that's probably still would have taken the data engineer a bit longer than we did there to build that out. To show you a little bit more of the capabilities, I can say, add some notes to the canvas, explain the...
This capability, where it really understands what the pipeline does, means it can generate git commit messages automatically. It can document pipelines that you have no idea what they're doing and so on. So it's a whole other level. We're showing you here transformation, but it also can do orchestration. It can build you custom connectors just based on an API reference doc. So there's a whole throughout the life cycle really that Maya can help you.
And as Frank mentioned earlier, it can work both ways. So it could be, I'm bringing the AI to look at the human-generated pipeline, understand it, check it, modify it. Or it can be, the AI has built, Maya has built the first draft of the pipeline, the human can then tinker with that. You see there, it's added some quite detailed notes on the calculations, its business logic. That can actually act as a sanity check for me as to what I've built. Is it what I want? Is it necessary? I can then, being a good and diligent person, say, okay, commit this to Git, please. It'll interact with our system there. We actually have obviously Git intro here. And if I didn't like what Maya generated, I can always reset my branch back to the last commit. So it's really easy to clean up if it's ever gone off piste or done something I didn't fancy. It's actually asking for permission. I'm not going to give it permission because I don't want to overwrite the pipeline for my colleagues demoing over on our booth and giving Maya the answer ahead of time. But it will also obviously generate that commit and will generate the commit documentation to go with it. So that's kind of end of where we were at with the demo, which actually gives us a couple of minutes. I think we've probably got room for. We've got 5 minutes.
We've got a few questions, so I think you've got the fancy microphones built in there. So if you've got a question, just raise your hand. We'll point to you and ask a question. I think everybody can hear you then.
I think he's got a mic run over the front.
No question. Everybody's stunned.
I think he needs the mic.
Okay. Oh, no, I thought you have a mic built in, right?
No.
No?
No, so we have to share a mic. Hopefully
Thanks. Just wanted to understand, is this limited to running on the Matillion architecture, or is it something that's available more widely?
Yeah, we'll take that. Yep. So this is running within the Matillion architecture, within our SaaS product, the Data Productivity Cloud. We do anticipate for the future that we would put this make this available behind an MCP server, so that maybe those that are working more in the data dashboarding space or the chat with your data space won't have a bot that chats with your data or builds reports and then calls to Maya to say, I need a new source.
The reason why it is, in quotes, limited to actually working across this DPC is, as we said, it works fundamentally different versus just generating SQL. So as a result, it needs all the capabilities of the platform underneath in order to, that's really why it's able to do things so much better. It can generate SQL, so you saw these components that it places there. It can have a SQL component, it can have Python components, we have AI components, right? So, and all of these get pushed down to the underlying data warehouse. So we'll execute instead of Snowflake. But it is for the DPC platform, for that end-to-end platform only.
Yeah, and a lot of the tools we're giving it are user-based things, the equivalent of being able to look in a drop-down and check the valid available values, for example.
Cool. I think we have time for one more question.
One more question? Anybody? Over the back there.
The crowd surfing microphone. I love it.
That works.
It works quite efficient, actually.
Yeah.
Hi, I just wanted to ask, like, does it produce some execution plan as well?
The underlying SQL gets pushed down to the data warehouse. The data warehouse is then the thing that will build the actual execution plan. It does have orchestration in, so it can orchestrate the running and the order and the sequencing of multiple pipelines and the recurrence operation. But the actual execution we push down to the warehouse, so different warehouses will use all their latest technology to optimize that.
Yeah.
Okay, so we assume that whatever it has produced is optimized, yeah?
And it is. I mean, that's because, right, like the SQL gets optimized, gets generated by these components. We have the luxury of, for each component, spend some time to make sure that the SQL that comes out is specific to each warehouse. So it's optimized for each of the different warehouses and their specific capabilities. So from that side, yes, we do believe it's fairly optimal. And, then Snowflake, etc., do their magic to further plan this and probably exceed what any human would be able to optimize anyway. So,
thank you.
So if hopefully you enjoyed the talk, thank you for being an attentive audience. Scan for a demo, or please stop by the Matillion booth if you want to hear more.
Because really try it out for yourself.
Yeah.
It's the thing that will convince you. Nothing we can say will convince you it actually works. So go and try it out. Just ask it random things and see what it does. Thanks so much for your time.